Okay, so now in this case, you z is equal to x plus iy and w is equal to this, and they're saying imaginary part of w is 0. You will show that this is equal to 1. Correct? This is not equal to 0. They've given you, and z is equal to x plus iy. So now w is equal to z is equal to x plus iy, right? Upon z square, that is x plus iy square plus 1. So that will be x plus iy. This will be x square plus I square y square, correct? Plus 2xyi plus 1. So that makes it x plus iy upon x square minus y square plus 1 plus 2xyi.
Okay.
Now we will multiply and divide by the complex conjugate, correct? So this will be x square minus y square plus 1 minus 2xyi upon x square minus y square plus 1 minus 2xyi.
I got you.
Now I just want the imaginary part. I want only to term that give me I.
Okay.
So I am not interested in anything else. So I'll just write imaginary part.
So only multiply iy.
Iy, so no, but x will I should care of. Which term in x will
The
give me
last
I?
part.
X with this.
Yeah.
Correct? So that time I'm looking at only, I'm actively looking at term that give me I and not write that I. So that will be 2x square y.
Correct.
I am not writing because I'm
Correct,
writing the
correct.
imaginary part.
Plus
Okay.
x
Plus
x square y.
now your iy when multiplied by this will give me a imaginary
X square
part.
y. Yeah.
So that will be y x square minus y square plus 1.
Yeah.
Because when this term in I gets multiplied by this real term,
Correct, correct.
I get a term in I.
Yeah.
Upon my denominator is a square minus b square. So plus 1 it will become I square minus 1. Correct? Is there any other term in I? Nothing. Now this imaginary part is equal to 0.
Yeah.
Okay. So when I open the brackets, so this will cross multiply. So I'll get 2x square y plus x square y minus y cube
Plus y.
plus y.
Equals 0.
Why am I doing this? It's better that I remove y common. Correct? What will be left with?
2x square
2x
plus
square
x square
plus
minus
x
y
square
square
plus 1
equals 0.
I'm making a mistake, sign mistake somewhere. Because you have to prove that x square plus y square is equal to 1. And this will cross multiply. This will cross multiply. So check for sign mistake. 1 second. Let's start from beginning. So x plus iy square, x square minus y square plus 1 plus 1.
So it should be minus I square.
Minus I.
When you make your I, so your I square becomes minus 1, no?
I square becomes minus 1. So basically your x will get multiplied by this, which will give you I, and y will get multiplied by this. Correct? So 2x square y, that is because of this, correct? And y into this. So I should get x square. Some mistake I'm making here, which I don't realize. Oh, this when I multiplied this by this, correct? This is minus. There's a minus sign which is there. Yeah. See now, this is minus now when I'm multiplying x by minus this na. So I didn't take the minus sign. So now it will come. So y is equal to 0. Or now when you combine this, minus x square minus y square plus 1 is equal to 0. Correct? Now they've said that y is not equal to 0. So this is not equal to 0. Therefore this is 0.
Yeah.
Therefore x square plus y square is equal to 1. Now your x square minus y square is mod z. No?
Yeah.
Because if your z is equal to x square y, mod z is the root of x square plus y square. Correct? So basically root of this will be root of 1. So therefore this will be 1. Yeah, it's blue. There's one sign you have.
Good question.
See, you have mod z is equal to 10. So let your z is equal to a plus b or x plus I y, whatever you call it. It won't matter. X plus I y. So that means your 5z will be 5 times, correct? X plus I y plus 10 upon x minus I y is equal to 6 minus 89. Now you multiply and divide by the complex conjugate.
Okay.
Means I have to get rid of the I in the denominator. Now either I take an LCM and do this. So 5x plus 5iy plus 10x plus 10iy divided by, what does this be?
X square.
X square plus y square. Equal to 6 minus 89. Now what's going to happen is you always try to think of the real part and the imaginary part. So 5x.
You take the LCM for that?
You may not. I am not taking.
Okay.
Because I always focus on getting the real part and the imaginary part. X square plus y square. That's my real part. Correct?
Right.
Plus my imaginary part would be 5y
Plus 10y over x square plus y square.
is equal to 6 minus 89. Now equate the real part with real part, imaginary part with imaginary part. So 5x plus 10x upon x square plus y square is equal to 6, correct? And your 5y plus 10y upon x square plus y square is equal to minus 18. Now we solve for x and y.
But so what do you use your mod z is equal to root of 10 for?
Oh, mod z I forgot to. I could have used that. So your mod z is the root of 10. Your mod z is root of x square plus y square is equal to root 10. So therefore x square plus y square is equal to 10. Yeah, you're right. So I put that here. So this is your basically 10. So 10. So this and this cancels. Correct? This and this cancels.
So x is equal to 1.
6x is equal to 6. X is equal to 1. This is 6y is equal to minus 18. Y is equal to minus 3. Correct? Therefore my z is equal to x plus iy 1 minus 3. That's it. Now what you're doing is not wrong. Other method. So you need to remember that z into z star. You can add that z into z star is mod z. Correct? Because that's your a square plus b square. Correct? So if I take LCM over here, z star, this 5z z star, correct? Plus 10 is equal to 6 minus 89. So z into z star is mod z. Correct? Plus 10 upon z star. Z star is basically a plus bi, you can call it. Correct? Is equal to 6 minus 89. I'm just thinking, okay, if you do this, your mod z, no, but still that z star to remains only, you can't do anything about it. Okay, so now what will you do? What is your mod z? Root 10.
Correct.
No, this is square.
Which way do you see?
Z square. So 10 this will become 50, 60 this will become.
No, but that's exactly what
Yeah,
I
yeah. 60. Yeah, okay, huh. Now listen. Yeah, okay. Now if you get this, then if you call this x minus iy, because that's your x plus iy, so 60 is equal
exact
to
same thing.
correct, good. Now what you can do is, this is your 6x, correct? Minus 6yi minus 18ix, correct?
So minus 18
Plus 18i square y.
So minus 18y.
Minus 18y. So 60 is equal to 6x minus 18y, correct?
Okay. Also real
Plus minus 6y minus 18x.
So we're saying 6x minus 18y is equal to 60 and
Correct.
minus 6y minus 18 is equal to 0.
Oh. Real part and imaginary part.
Oh, so what I did also worked. I just need
It will work, yeah.
Okay.
Minus, correct? So y is equal to minus 3x. So minus 3x will be put in. It will be longer, but it will work.
Yeah. No, what you did makes more sense.
God, man, 18 3s are 54. 60, yeah. 60x is equal to 60x is equal to 1. And y is equal to minus 3. Yeah, here you get it.